Okay, exploring and celebrating horizontality by co-architects. This presentation by co-architects, it's about how architects approach a building. It is also about how architects interact with the fit facade to approach the design of a building. They are exploring the fit facade in a more potential way. According to co-architect team, a fit facade can push toward a deeper interaction between adjacent buildings, blurring the lines between individual communities and urban developments. According to the co-architect teams, a fit facade needs to fit the context aspect, economical aspect, environmental aspect, functional aspect, and comfort aspect. The fit facade, according to the co-architect's, roof or fit facade is being loaded with mechanical equipment and most of the time is inaccessible to its occupants and visitors, covered with cheap and badly performing assemblies. In other words, fit facades has been remained somewhat forgotten. Fit facade versus vertical planes. Fit facade has become more performative and they have been used for water conservation and energy collection. Fit facade has also the ability to offer a more direct experience of the space to its visitors and residents. Fit facades maximize the footprint of a building, allowing space for interaction and relaxation, versus vertical planes provide more aesthetical look. According to co-architects, there are four strategies of using the fit facade to achieve different goals. One goal can be wellness, using nature to improve the recovery of patients. Another strategy to use fit facade is shelter, where it is used as a shading structure. Another strategy is movement that can be used as a transition structure, allowing people to move from one space to another place. A structural can be used as a structural element for social interaction. The fit facade used for wellness is being presented in the Palomar Medical Center at Escondido, California, in the building. It is the idea of using nature for the healing process. Multiple scientific researches have been shown that nature has the possibility to speed up the healing process of patients. This concept is about bringing nature as close over the building and into the building. Bringing exterior context nature inside the building in front of the recovery section spaces. Bringing exterior nature inside the building in front of the recovery section help patients to get a faster recovery. Exterior vegetation roof used as an area of relaxation for visitors and doctors before they get into surgery. The roof, this vegetarian roof is called a cafeteria, allowing spaces for staff and allowing meeting spaces for staff and doctors. It is important to care about patients, but it is also important to care about caregivers, and it is how spaces like this are designed to improve their health as well. Roofs, fit facade as these are also designed as a water collector to maximize the water conservation of the building.
OHSU, the Collaborative Life Science Buildings, is the second project that the architect presented to us, and this one has to do with the subject of place. It's a 650,000 square feet building, including parking, and it features lecture halls, classroom, labs, especially research centers. And this is important to mention that this is a transit-oriented development. Here we can see some diagrams that explain the design of the project according to the natural conditions, where the summer wind and the winter wind played an important part because they use this element to naturally ventilate the building. And as we can see in the diagram, they have an efficiency of 45% energy savings. And in the diagram, we also see how they use natural light to illuminate almost the entire building. Now, one of the other important aspects of the design is to create comfort places, and we can see in this pictures how the architect include artists to do installations to create really peaceful and good places to be. And in the right hand, we could see the structure that it took to develop this architecture. The third project, it has to do with movement. This project is the Loyola Marymount University Life Science Building. And the interesting feature about this project is the ramp element, and that has the connection between the first floor and the third floor of the architecture. As you can see in the floor plan, in the site plan, the red arrows represent the trajectory that you will take to go to from the first level to the third level. In this render, you are able to have another perspective of this circulation, where you have some stairs and you have a natural garden. And in the far right, you can see the interior and the exterior render. And in the exterior render, you're able to see the primitive condition of the site where the dirt was part of it. Now we could see more technical stuff since we're dealing with a roof garden. This is the elements that it needs to take to avoid the moisture out of the building. And in the upper left, you can see the panelization that it took to design this building, where almost all panel needed to be custom. And the last project that this present to us is the shelter, that is related to shelter. And the architect mentioned that this was the project that it really enhanced their philosophy of design. It consists of a shelter, a shading structure that is above the entire building. Here you can see the partie diagrams that show the development of the site, how the architect wanted to do a circulation for the people to go completely across the building and inside the building without any obstruction, and how this shading element became the thing that unites both buildings. The total efficiency that this shade provides is the 30% efficiency of cooling, 50% less use of fans, and 20% less use of pumps. All this because the architect planned to use this as a roof building, and this will get a lot of natural environment inside the building.